Hi everyone. So let's go over what we would have done in the Zoom session today, 3.1 to 3.3 and 3.8, which will get you all ready for the quiz coming up. Let's start off by finding the derivative. They give you f of 5, f prime of 5, g of 5, and g prime of 5. So the first thing they ask you is this f times g prime of 5. So that is a product rule. So we have the derivative of the first times the second plus the first times the derivative of the second. And then we're just going to plug the values in. So we know f prime of 5 is 6 times g of 5 is negative 3 plus f of 5, which is 1, times g prime of 5, which is 2. Negative 18 plus 2 is negative 16. So that's how you do that one. The second one is a quotient, right? F divided by g. So that's the derivative of the first times the second, which is the bottom in this case, minus the first times the derivative of the second, all over the second squared. So remember that in the bottom, the denominator, that's the same as whatever was in the denominator, so the second squared. And the reason that I do the product rule in the order that I do, and I don't follow the way that the book did it, is because the product rule and the quotient rule are then the same, except instead of a plus, you have a minus, and you have all over the second squared for the quotient rule. So if you remember the derivative of the first times the second, plus the first times the derivative of the second, that is the same as the derivative of the first times the second minus the first times the derivative of the second. That's why I do it that way. And again, you would plug in values. I'm going to spare you that step right here. And then part C is just asking you g divided by f. So you would do the derivative of the first times the second, just swapping the order this time, minus the first times the derivative of the second, all over the second squared. And again, you would plug in the values as they give them to you in the original problem to get your final answer. Let's move to the next question. So we need to make sure we know how to do this. This is one that a lot of people missed on their homework. So this is x times e to the x times cosecant of x. And so note, these are three things being multiplied together. So there's two ways to approach this problem. One way would be to group this is the first and this is the second. And the other way would be to just use this as the first and then group these two together as the second. And I'm going to just do both of them for you here in this video so that you're comfortable with both approaches. You're going to get the same answer at the end. So I'll call the red one method 1. And so that's where I'm grouping the x e to the x together as my first. So when I take the derivative of the first, okay, I'm going to give it some room here. And I'm going to call that the derivative of my first. And then I'm going to do times my second plus the first. And then I'll have times the derivative of the second. Okay, so I just kind of set up a placeholder for myself. So what is the derivative of the first? Well, the first is x times e to the x. And to take the derivative of x times e to the x, I actually need a product rule. So to take the derivative of the first, I need a product rule within that. So the derivative of x e to the x is going to be 1 times e to the x plus x e to the x. So that whole thing is the derivative of the first times the second plus the first times the derivative of the second. And the derivative of cosecant x is negative cosecant x cotangent x. Okay, now on the quiz, do you need to know that formula? Look at the quiz hints and see, is that on there? If it's not on the quiz. So I will give you hints for which ones you need to memorize for this quiz. Method 2. Now let's group just the x as the first and the e to the x times cosecant of x is going to be the second. Okay, so again, I'm going to give myself some placeholders. Derivative of the first times the second plus the first times the derivative of the second. Okay. The derivative of the first, the derivative of x is just 1. Well, that was easy. Times the second, okay? Plus the first, well, that was just an x, times the derivative of the second. And the derivative of e to the x cosecant x, again, that's a multiplication problem, so I need a product rule in order to take the derivative of the second here. So the derivative of e to the x is e to the x times cosecant x, the second, plus the first times the derivative of the second. And the second is cosecant x here. So the derivative of cosecant x is negative cosecant cotangent. Okay, so that whole thing right there is the derivative of the second. Now, I'm not going to multiply it all out, but you can probably tell that these two things are equal to one another. But this is really like a double product rule type of thing. And I think that by laying it out to yourself like I've done here, like the derivative of the first times the second plus the first times the derivative of the second, laying that out will help you deconstruct this problem and make sure you don't make any stupid mistakes. So now let's tackle this problem. It says, given k of x equals x times f of x over g of x, find k prime of negative 2. So to find k prime of negative 2, the first thing you need to do is find k prime of x. And we see that this is a quotient, right? We also see there's a product on the top. But the first thing we see is that there's a quotient. Within doing the quotient rule, we're going to need a product. We're going to call this top one the first, and we'll call this bottom one the second as I'm talking. So the derivative of the first, the derivative of the top is going to require me to do a product rule. So the derivative of this first is 1 times f of x plus x times f prime of x. Okay, that was the derivative of the first times the second minus the first times the derivative of the second all over the second squared. And now I can plug in the negative 2. You always must find the derivative before you plug in a number. If you plug in a number from the get-go, the derivative is just going to be the derivative of a constant is going to be 0, right? So make sure that you're taking the derivative first. All right, so we have f of x, which is going to be f of negative 2, and then we have plus x. And what is our x? Our x is a negative 2, so I'm going to make that a minus 2 f prime of negative 2. That whole thing is going to be multiplied by g of negative 2 minus our x is just a negative 2, minus a minus 2 is plus a 2, f of 2 times g prime of negative 2. Oops, that was a negative 2. All over g of negative 2, that quantity squared. Now I'm going to look over at my table to finish the problem. F of negative 2 is 3 minus 2 times f prime of negative 2 is 1. So 2 times 1 is 2 times g of negative 2 is negative 5 plus 2. F of negative 2 we said was 3 times g prime of negative 2 is negative 5 all over g of negative 2, which we just said was negative 5, squared. So 3 minus 2 is 1. And oops, I just caught something. This was g prime of negative 2, and I should have used an 8 there, not a negative 5. Okay, that's better. So now I have a 1 times a negative 5, which is a negative 5, and then I have 2 times 3 is 6, and 6 times 8 is 48, all over 25. So I have 43 over 25. That's going to be my final answer. All right, so we need to know this physics application. This is really, really important, and it's important to justify all of your work. So when they're asking you find the velocity, that is just the derivative of the position function. That's all you have to do. Easy. When they're asking when is a particle moving right, it moves right, or it moves forwards, or it moves up when the velocity is positive. It moves left, it moves down, it moves backwards when the velocity is negative. To justify your work, you have to say because velocity is greater than 0. Just putting a number line will not give you justification points. It will not give you points on the AP exam, and so I'm going to get you in the best practice of fully justifying your work right now because it's never too early to do that. Moving right because velocity is greater than 0. You just got half credit in my class, at least, not on the AP exam, but on my class, you did. How do I figure out where velocity is greater than 0? Well, I had this velocity equation, and to know where it's greater than 0, I notice that the denominator is always going to be positive because it's squared. So really all I have to pay attention to is the numerator, and then you find, t squared equals 1, t equals plus or minus 1, so you would put it on a number line, and we know it's negative, positive, negative. You could put in numbers here, or this is a parabola opening down like that, and so it would be negative, positive, negative. You want to know where it's positive, and it's positive between negative 1 and 1. However, time can't be negative, so it's just from 0 to 1 seconds is our answer there. Find the total distance traveled. I'm going to take that one to this next question because I want to do the total distance traveled in the first 6 seconds. The original question had asked you to find it just between 1 and 6 seconds, which was pretty easy. It's not much harder this way, but I just want to talk about this. We knew that it was moving right between 0 and 1 seconds, and then it's moving left from 1 on, right? And we're just doing the distance traveled in the first 6 seconds. But I know that between 0 and 1, okay, I'm going to find the displacement between 0 and 1 and add it to the displacement between 6 and 1. And the reason I did that is because I'm thinking about adding up my forwards and my backward steps. Because pretty much if I had moved, forward 3 steps and then I go backwards 1 step, my displacement, I'm only 1 away from where I started, but I've moved 1, 2, 3, 4 steps total. So you have to add up your forward steps and your backward steps. Now this is going to be positive, right? Because we knew it was moving forward there. So I don't really need the absolute value. It's going to be positive anyway. But you may as well just put the absolute value on all of the positive regions versus the absolute value on all of the negative regions. And then you're going to find your total distance traveled. You need to put this back into your original position function. You want distance traveled, right? So your key there is distance traveled is going to be measured in meters, right? Your answer is going to be in meters total. And so which equation are you going to put it in? You're going to put it in the equation that's measuring in meters. So obviously you want to put these numbers back into not the velocity equation, but the position equation. What are you looking at the velocity equation for? You're looking at the velocity equation to tell you where is it moving forwards versus backwards. So you need the velocity to find the intervals, okay? So that's these intervals that you use. You use the velocity to find the intervals, then plug into the position function to calculate your final distance. Got it? So how am I going to do this? I'm going to pull up my calculator in Y1. I'm going to just put in my position function. That was x over 1 plus t squared. So I'm going to just put 1 over x squared. Okay, I'm putting in my position function, not my velocity function. Then I'm going to go back to my home screen. Clear. If you want the absolute value, the easiest way to do it is catalog. The first thing in catalog is absolute value. So that's my go-to. Then go to vars, y-vars, and we're going to do y1 of 1 minus y1 of 0 plus absolute value, y1 of 6, because that was the ending time they gave us in the problem, minus y1 of 1, and there's our answer, 0.8378 meters. And remember, you need at least 3 decimal places in your final answer. Not just 3 decimal places, but 3 decimal place accuracy, okay? To justify your work, all you need to do is show this step right here. That step right there is fully justifying your work, okay? In general, to find where the particle is moving left, we want to see where the velocity is negative. Where the velocity is negative, the particle is moving left. In general, to find where the particle is speeding up, we can simply look at the answer here is simply look at the velocity function. And let me explain to you why. Remember, speed is the absolute value of velocity. And it's speeding up. You know, when it's positive and increasing, it would be speeding up, right? If I'm going from 2 miles per hour to 3 miles per hour, I'm speeding up. Easy. But if I'm going from negative 2 miles per hour to negative 3 miles per hour, because speed is the absolute value of velocity, I'm also speeding up. When the velocity is positive and the velocity is increasing, it's speeding up. But also when the velocity is negative and the velocity is decreasing, its absolute value is still getting bigger, right? Then we have speeding up regions. In essence, whenever a particle on a graph is moving away from the x-axis, it is speeding up. So positive and increasing or negative and decreasing. How do I actually calculate this? This is the region of speeding up right here, right? Because it's negative and decreasing. I don't have any positive and increasing in this one. So to find this, I would find the 0 on my calculator. So you go to second calc and you find the 0. And to find this second point here, that's our minimum, right? So you're going to go to second calc the minimum there. So this is the wrong graph on my calculator. But if I wanted to find a maximum, I go to second calc, maximum. I go a little bit to the left of the point, and then I go a little bit to the right of the point. And you must go a little to the left and a little to the right. And then you do a guess, which is in the middle. And you have to go a little to the left and a little to the right. If you don't, you're not going to get the right answer, or you're going to get an error, because the way that the calculator works is it kind of takes the left that you did and the right, and it gets them closer and closer from the left and the right till it finds a point where it's the biggest between them. So if you don't go a little to the left and a little to the right, it won't work, okay? So that's how I find my maximum. To find my 0, you do the same thing. It says left bound. So if that's my point, you go a little bit to the left, enter, a little bit to the right, enter, and then you go in between, enter. Okay, you must go a little left, a little right, and in between. Moving right along. So when is the speed the greatest? The speed is the greatest. Remember that speed is the absolute value of velocity. So where is the velocity at its biggest? Have told me many times that we know that we have a max or min when the derivative equals 0. Now that's not a sufficient answer. We're going to learn more about how to find maxes and how to find mins, okay? But the derivative of velocity is acceleration. So that was why we looked at acceleration in that problem. So it's just a very brief explanation. You're not being quizzed on that at this point, okay? Just wanted to bring it up as a discussion point for now. And we'll talk more about it as we get into mins and maxes and how to justify those fully. Okay, but just think about it. To find the maximum of velocity, we're going to look at the acceleration because it's its derivative, okay? Oh, and I realized I didn't fully finish this problem right here, taking you through a full justification of speeding up and slowing down, because you really need to justify this answer. So speeding up, the easiest way to write your speeding up justification, in my opinion, is when velocity and acceleration have the same sign. Okay, I thought I told you only look at the velocity graph. I did, and I meant it. Even just looking at the velocity graph, I can justify that v and a have the same sign. I do not need to look at velocity and acceleration to justify that v and a have the same sign, okay? Why? Because they have the same sign means that velocity is positive and acceleration is positive, or velocity is negative and acceleration is negative. What does acceleration positive mean? Remember that we have position, then the derivative of position is velocity, then the second derivative of position, which is the derivative of velocity, is acceleration. We learned that relationship. So acceleration is equivalent to the derivative of velocity. So acceleration being positive is equivalent to v prime being positive. And what does the derivative being positive mean? The derivative being positive means that the function is increasing, right? If it has a positive slope, it must be increasing. So velocity being positive and acceleration being positive, I can justify that all by just looking at the velocity curve, because these two statements are equivalent, right? Same thing goes around. So the acceleration being negative is equivalent to v prime being negative, and v prime being negative is equivalent to the velocity decreasing, okay? So I can just look for v is greater than 0 and v is decreasing. Again, I think my easiest justification is just to write this on my paper and then look for these things. Those things happening together or those things happening together. Got it? Good. Moving on. Find the equation of the normal line. All right, to find the equation of the normal line, I need a point, I need a slope. So let's start with the slope. The derivative, I'm going to call this the first, I'm going to call this the second. The 2 is just a constant, so it's not really going to bug me. It's not going to be hard. The derivative of the first, the derivative of 2e to the x is 2e to the x times the second plus the first times the derivative of cosine x is negative sine x. Now I'm going to find the derivative at the point. So y prime of 0 equals 2e to the 0 cosine 0 plus 2e to the 0 times negative sine 0. Okay, 0 is right here. My point is 1, 0. So the cosine is 1. 2e to the 0 is 1. Cosine 0 is 1. 2e to the 0 is 1 times negative sine of 0, but sine of 0 is 0, right? So 2 is our slope. But the slope of our normal, that's the negative reciprocal. Now I have a slope. What's the point? The point, I know the x-coordinate is 0, so y of 0 is 2e to the 0 cosine 0. Cosine 0 is 1, so my point is just 0, 2. So y minus y1 equals the slope, x minus x1, so y equals negative a half, x plus 2. That is the equation of my normal line. Remember, that's the perpendicular. Evaluate each of the following limits. So this first one, where's my a plus h? It's like invisible. I just see the h. So couldn't I put in a 0 plus h? Let me show you how that's going to help. So this is probably the limit definition, where f prime of a equals the limit as h approaches 0 of f of a plus h minus f of a all over h. We have to see if these follow that definition or not. Okay, so the first one, is this equal to f prime of a? Our a in this case is 0. F prime of 0, where f of x equals e to the x, right? E to the a plus h, e to the x. We need to check it out. So we need to make sure that this is actually our f of a. So our f of 0 in this case is e to the 0, which is 1. Yes, it's of the proper form, so I can proceed. Let's evaluate. They want us to evaluate this. So this is the definition of f prime of 0, where f of x equals e to the x. So that means that f prime of x is going to be e to the x, because the derivative of e to the x is e to the x. And f prime of 0 is e to the 0, which is 1. So my answer to this question, my final answer, is 1. Okay? Now the second one, probably going to be the same type of thing, equals f prime of a plus h, this is 2, where f of x equals e to, now I have e to the 2 plus h, so e to the x again, right? E to the a plus h in this case. Now I need to check before I move on, is this of the proper form? So f of 2 in this case, right, because my a is now 2, is e to the 2, so yes, that checks out. It is of the proper form, all over h. And so what do I have? F prime of x, again, is going to be e to the x. This time I want to find f prime of 2, though, so I have e to the 2 is my final answer. Last one. So I'm thinking that this is f prime of 8, right? Where f of x is, what am I doing to the a plus h? I'm cube rooting it, x to the 1/3. But before I proceed, I need to make sure it's actually of the proper form. So f of 8 is 8 to the 1/3 power, which is 2. Yes, it checks out. It's of the proper form. So f prime of x is going to be 1/3 x to the negative 2/3. 1/3 minus 1 is negative 2/3. And then I want to do f prime of 8. And so that's going to be 1 over 3. I'm going to just put that 8 to the 2/3 in the denominator. And if I can't use a calculator, then what you want to do is you want to always break things down before you build them up. So when we have 8 to the 2/3 power, make sure that you do the cube root first so we can break it down. So 8, the cube root is 2, and then 2 squared is 4. Always break it down before you build it up. So 1/12 is my answer to this one. Moving on, we want to fill in the blanks now. So we want to put it of the proper form. So in this first one, I have h plus a, right? I just mixed it up a little bit there. So if our f of x is the square root of x, then our a is just going to be 16, right? And if this is going to be of the form f prime of 16, the limit definition of that, then this right here has to be my f of a. So right there, we would have to have a 4 in order to be able to evaluate it, as we have using the shortcut method. If that wasn't a 4, if it was a 16, say, then the only way I could evaluate that limit would be to multiply by the conjugate like we did at the very beginning of the course. So I can only use the shortcut method that we were using here if they're of the proper form. So if this is actually the f of a there. Okay, so that's something to keep in mind. This next one, I have a plus h. So our a is going to be 2. And then our f of a is going to be 2 cubed. 2 cubed is 8. In this last one, this one is clearly the other definition. So this is the limit f prime of a, limit as x approaches a of f of x minus f of a all over x minus a. So in this one, the a is this, and this is the f of x. And then this is still my f of a. So my f of a is going to be 3 to the 4th power. 3 times 3 is 9, and 9 squared, 81 there. So in order to be able to use f prime of 3 definition, there would have to be an 81 right there. Find the equation of the tangent line. All right. So the derivative of secant x, y prime is secant x tangent x. Now we need to evaluate that at the point pi over 3, right? So y prime of pi over 3 is secant pi over 3 times tangent of pi over 3. Now what if I told you no calculators allowed? How do we do this? Well, we know that secant is 1 over cosine. We know that tangent is sine over cosine. So pi over 3 to me, when I think about it, pi over 3, 180 over 3 is 60 degrees, okay? So 60 degrees. Across from the 60 degrees is root 3 over 2 when this is 1 and this is 1/2, okay? That is my theta. Secant, again, 1 over cosine. The cosine of pi over 3 is 1/2. So the secant of pi over 3 is just going to be 2. And then the tangent is y over x. So tangent of pi over 3 is root 3 over 2 over 1/2, which is the same thing as multiplying by 2. And so that's just root 3. So 2 root 3 is my derivative. And then I have a point. They already gave me the whole point. That's very nice of them. Y minus y1 equals the slope times x minus x1. My final answer, just put it in y equals form for me, please. X minus pi over 3 plus 2, boom, I am done. A couple more. If the question is find df dr, given f equals this, what are the constants and what are the variables? So we have single variable calculus. We're only dealing with a single variable in this course. The derivative of force with respect to r is what's changing over time, all right? So that means that the g, m, m are all constants, and the variable would be the r. If I want to find the derivative of it, this means the derivative of the f, the derivative of the force, with respect to r. R is our variable. So let's rewrite f equals gmm r to the negative 2. That makes it much easier. Then this whole thing is a constant. Remember when we take the derivative, it's the same thing as f prime. We can let the constant hang out. And then the derivative of r to the negative 2 is negative 2r. Negative 2 minus 1 is negative 3. So our final answer, negative 2 gmm r to the negative 3. In the homework, we did a problem like this, and they asked us find p prime of 1920. And we did that by finding the slope between 1910 and 1920 and finding the slope between 1920 and 1930. And then we averaged these two. And that was how we found f prime of 1920. Or p prime, that was the population. Now, what if they asked us find p prime of 1900? Well, 1900 is an end point here. So I don't have anything, I wasn't showing you what I was doing. I was saying that 1920, I find the slope between 1910 and 1920, and then also the slope between 1920 and 1930 because I have points on either side, and then I average those two to find p prime of 1920. So that's going to be the average of what's on the left, a little bit to the left and a little bit to the right. But at 1900, I don't have anything a little bit to the left. So instead, what I'm going to do is the best that I can. And the best that I can is just use 1900 and 1910 and find the slope between those. So I'm going to approximate p prime of 1900. In this case, the best I can do is do 1750 minus 1650 all over 1910 minus 1900. That's the very best I can do. I can't do any better. I can't average it with anything else. I just take the 2 points that are closest to one another. And then my answer is going to be in millions per year. Okay? My answer is going to be a positive number. So that means that the population at 1900, okay, in the year 1900 was growing by however much I find there. Okay? That's what it means. It means at the moment. P prime in 1900 means at that moment in time, that's how much it was growing. If I had had a negative number, it would have been at that moment in time. That is how much the population was decreasing. Heads up, make sure that you understand how to do 3.8 number 1, which was also on the review sheet. Make sure you know how to do all the parts that will be asked of you on the quiz for certain. For sure. If you don't understand, be sure to ask. Be sure to look it over. You can rewatch the 3.8 video. That might be a good idea if you're confused at any part of it, and you do need to justify your answer. So when they ask you, when is the particle moving in the positive direction? Because velocity is positive there. When is the particle speeding up? Because velocity and acceleration have the same sign, and you can just look at the velocity curve to figure that out. Your homework is going to be to complete this last problem. This will help you for the quiz, okay? And this is also an actual AP problem that we can actually do parts A and B of already. It's very exciting. And I threw in one more part. Please find all intervals where the particle is speeding up. So you will do this for me and you will hand it in. Are you ready for the quiz? hopefully thumbs up on that. Anything else you need to tell me, just leave me a comment and let me know. That should get you ready for the quiz. The last thing I want to tell you, class, is about the test, okay? So this is just a heads up. You see that our test prep, actually, we finished the last section right here. And then we have test prep starting on Friday. We have test prep on Monday. Really, your test could be on Tuesday or Wednesday. Problem is that it's a gold week. So we can choose to take the test here, or we're going to have to start chapter 4 and then take the test on a blue week. I don't know that you want to wait a week. Again, it's up to you. I can't test you on a gold week unless everybody in the class wants to take it a gold week. I'm sorry that it didn't fall in a better place. Please, in Slack, I'm going to ask you guys what your preference is. Do you want to take the chapter 3 test after you have 2 days of review? Or do you want to do all this chapter 4 stuff and then you have to remember chapter 3 the week after? You guys let me know. I can probably be flexible and allow you to take the test either on the Tuesday or the Wednesday. So that would give you a little bit more flexibility there. Again, you let me know what you need. That's it for this lesson. Bye.